This hearing will come to order. Good morning. I want to welcome everyone to today's hearing on harmful algal blooms, HABs, and how these HABs are impacting our coastlines, marine, and freshwaters. Our marine and freshwaters are overflowing with life. However, under the right conditions, some of the naturally occurring microorganisms found in these waters can create toxic conditions. Harmful algal blooms can cause a tremendous amount of damage through the production of toxins and by reducing oxygen in the water. Many of our coastal areas and the Great Lakes are experiencing the impacts of these blooms. These impacts include alteration of the ocean's food web, human illnesses, and economic losses to coastal communities and commercial fisheries. Our Texas Parks and Wildlife Department monitors these blooms to communicate pollution threats to the public. They have continued to work hard to respond to incidents where fish and other animals have been harmed. The research and response needs for the U.S. have grown since the last reauthorization of the Harmful Algal Bloom and Hypoxia Research and Control Act of 2004. There has been an increase in the number, frequency, and type of HAB. We need to use the advances in our understanding of these blooms to better predict their occurrence and to prevent them, if possible. Fishery and beach closures are very costly events that can devastate the economies of coastal communities. We have a distinguished panel of witnesses here today, and I hope they will offer us recommendations on how we can improve the prevention, control, and management of harmful algal blooms. And I want to thank all of our witnesses for being here today, and at this time I'd like to recognize actually not the ranking member of the committee, but of the ranking member of the full committee, Mr. Hall.
I thank my fellow Texan, and I have a statement, and I'd ask unanimous consent to place it of record and not take the time.
So ordered. And if there are additional opening statements, they will be placed in the record at this point. At this time, I am pleased to introduce our first panel of witnesses. We have two of our colleagues from Florida. Well, we have one of our colleagues from Florida with us today, Representative Connie Mack. We may be joined by Representative Alan Boyd. Congressman Mack, you are recognized to make your statement.
Thank you, Mr. Chairman. And if it's okay with the committee and the chairman, I have my written statement that I'd like to submit to the committee. But if it's all right with the committee, I'd like to just talk openly about red tide and algae blooms and the effects that they have in my part of the country and what I think the overall impact is, if that's okay with the chairman.
It is absolutely perfect with us. Please proceed.
Thank you. And I'm sure that I know that most people behind me and also people on the committee are aware of the problems, and I will refer to it as red tide. There's lots of different names for these algae blooms and the toxins that are produced from them. But just from my perspective, growing up in Southwest Florida, we would have a red tide incident that would last maybe a week, a year. And now we see red tide off our shores and approaching our coastlines 13 months in a row. So obviously the problem is getting worse. And as we try to learn more about red tide and the causes of red tide, we always bump into competing research. Someone will say that, well, research shows that it is not tied to maybe runoff, let's say, from fertilizers running off into our bodies of water. And others will say, well, the science doesn't prove that at all. And then we get members of Congress, such as myself, who'd like to go home and take a couple $1 million and go to our local university and hopefully help them with their research projects. But then we find that we end up duplicating research projects. And so one of the things that I have proposed, and I think we have 40-some co-sponsors on the bill, is to have a peer review research, so that when we move forward with red tide research, the monies are being distributed by scientists who understand the research. So we don't duplicate research as we move forward, and there's more efficiencies. This is not just a Florida problem. This is all along the coastal of the United States, also the lakes, and red tide. These algae blooms are different in every part of the country. But we can use, if we can combine our dollars, if we combined our research and our efforts, and we let the science and the scientists direct where those dollars are going, we will get a much better product. The research will be much more reliable. And from that research, we can then move into how to better track red tide, how to use the research to develop technologies that will limit the red tide outbreaks. And if you've ever had the opportunity to visit Southwest Florida, some of the most beautiful beaches, I know, other parts of the state might disagree, but some of the most beautiful beaches in the country or in the world. But when you have a red tide an event, people have a hard time breathing. It runs people out of our hotels. The economy suffers, and there's a long-lasting impact to the citizens of Southwest Florida, who have a hard time breathing, and their eyes will swell and tear up, and it's very uncomfortable. And so we'd like to. I'm encouraged that the committee is again looking at how we move forward. How do we continue to have research that's done in a way that will that is reliable, that is efficient, that we don't waste taxpayers' dollars on duplicating of research. And I think that that the committee and the wisdom of the committee will find a way to ensure that we use peer review research instead of powerful members of Congress fighting just for their backyard, but fighting for all of us around the country and taking on red tide. Thank you, Mr. Chairman.
Thank you, Mr. Mack. We appreciate you being here. Mr. Boyd, you're recognized.
Okay. I needed my friend Connie Mack to show me how to turn this thing on. I thank you, Mr. Chairman, and Representative Hall and other members of the committee for allowing us to appear for you today, and thank you for holding this hearing. And I apologize for being a moment late. You know, most committees are a little bit late starting on time, Mr. Chairman Lampson, but obviously you're not, and I'm grateful for that. I'm also grateful for my friend Connie Mack and his leadership in this issue. And he is absolutely right that Southwest Florida has some of the most beautiful beaches in the world. The problem is he doesn't have the most beautiful beaches. That's in North Florida. And in areas like Panama City, Destin, the Fort Walton area, an area that we've so endearingly called the Redneck Riviera.
These aren't commercials now, are they?
But red tide is gotten to be a very serious problem, and it's become more severe. I know when I was growing up, it was something we didn't see very often, and we dreaded it when we did see it. But in the last 15 years or so, we've had maybe 5 or so severe outbreaks. And I think the important thing to understand is when that outbreak comes, it really renders the coastline and the use of the coast worthless, not only for commercial activity like fishing because of what it does to the fish, but also it renders it useless for human use. People can't use the coast when there's red tide, and so you see that those of us who live in coastal areas, and in Florida, 80% of our people do live within 12 miles of the coast. That's what Florida was built on, is our beautiful coastline. So it does extreme damage to us economically, in addition to the ecosystem environmental damage that's done also. Specifically, I think in our area, we have a very aggressively growing community up in the Destin, Fort Walton, Panama City area that has turned into quite a tourist spot. But we also have a long and historical, productive fishing industry, particularly in the Apalachicola Bay area. We're home of the world-famous Apalachicola Bay oyster. And when the red tide comes in, then all of that is rendered useless. Particularly this last outbreak we had after Katrina, we had an outbreak, and then subsequently the drought, which happened in Georgia, and the reduced amount of fresh water coming down the Apalachicola River. We weren't able to flush that red tide out, and it stayed with us an extra long time. So those are the kinds of problems that we experience with the algal bloom that causes the red tide. And Mr. Chairman, I want to again thank Connie Mack for his leadership on this issue, and also for you and your committee for holding this hearing. And we'll be glad to answer whatever questions that we can, with the hopefully with the understanding that you know that we're not technical experts on this, but we just know how it affects our people and our communities. Thank you very much.
Thank you very much, Mr. Boyd and Mr. Mack. Are there any questions of this panel? We've got some experts that are sitting behind them that we're going to be hearing from, but we have questions if anyone wants to now. Yes, sir.
I just say it's an exceptional pair here that are here with the similar problems of a mutual state, and I like the way they brag on their particular districts, because I'm reminded that Pikes Peak is not by far the highest peak over in that area. There are 4 or 5 other higher peaks, but Pikes Peak is the one that congressman brags about there, and that's where everybody goes. So that's, maybe each of you have a Pikes Peak in your district, but all the parts of Florida that I've ever visited are just absolutely breathtaking. And I have a great opportunity to be with you, Mr. Boyd, almost once a year for the last several years, and you're a gracious host, and you have represented a beautiful part of the country. My first home during World War II was Daytona Beach, Florida. And my wife and I always intended to go back there, but, you can't do that when you have families at home and fathers and parents and all. But it's a great state. You do a good job. Thank you for coming before the committee.
Mr. Chairman, if I might thank my friend Ralph Hall for those comments, and Connie Mack and I certainly would agree that the Atlantic coast is the second most beautiful coast in the state of Florida, with the Gulf of Mexico being the first.
I would agree with that.
They are together on something. I would question as to whether or not the best fishing is in the eastern Gulf or the western Gulf, but we won't get into that either today.
Well, since you brought it up, Mr. Chairman, depends on what you're fishing for.
That's very true.
But I would suggest, on a serious note, I know that I've had an opportunity to talk to members of the committee, and I know that you're going to hear from the experts on this, and I'm fortunate enough to have had the ability to have many conversations with who I believe are the experts, and I think my colleagues recognize the need for us to once again move forward with the ability to have research that's meaningful. Because research is what we rely upon to develop the technologies to protect our waterways from these toxins. And so I'm very honored to be here and to have the opportunity to speak, but I really look forward to you hearing from the experts as well.
Well, we thank you both for being here, and clearly it's a huge issue. It affects the food chain, it affects our tourism activities, it affects the economy significantly, and we hope we come up with some of the right conclusions that need to. So thank you both for joining us today. We will take a very short break as the next panel takes its place at the table, and we will begin very shortly. Well, I want to welcome our second panel of witnesses. Dr. Robert Magnian is the director of the National Oceanic and Atmospheric Administration Center for Sponsored Coastal Ocean Research. Dr. Donald Anderson is senior scientist and director of the Coastal Ocean Institute at Woods Hole Oceanographic Institution. I'm going to skip Dr. Ayres for just 1 second and go to Dr. Kenneth Hudnell, who is the vice president and director of science at SolarBee Incorporated. And I would call on our colleague, Mr. Baird, to make an introduction.
I'm just pleased to have Dr. Dan Ayres here, Coastal Shellfish Manager and Lead Biologist for Washington State's Department of Fish and Wildlife, Region 6. We have, my dear friends from Florida spoke earlier, but as Dan knows, we have harmful algal blooms off our coast and in the Puget Sound as well, and Dan's been a real leader in trying to deal with those, and I'm glad he's here. Thank you, Mr.
Thank you, Mr. Baird. Well, you'll each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing, and when you all complete your testimony, we'll begin with questions. Each member will have 5 minutes to question the panel. Dr. Magnian, you may begin.
Can you hear me now? Good morning, Mr. Chairman and members of the subcommittee. My name is Robert Magnian, and I'm director of NOAA's Center for Sponsored Coastal Ocean Research. My center is responsible for administering the competitive research program called for in the Harmful Algal Bloom and Hypoxia Research and Control Act, also known as Abarca, which includes the only 2 national programs devoted solely to harmful algal bloom research. You'll hear me refer to harmful algal blooms as HABs in the rest of my testimony. Appreciate the opportunity to discuss NOAA's role in the national response to HABs in our coastal waters and our Great Lakes. I'll briefly discuss what HABs are, highlight NOAA's approach to this problem, and touch on some of our accomplishments to date. Harmful algae are often invisible microscopic organisms, but they can also appear as visible scums or be seaweed-like. Some harmful algae produce potent toxins that cause illnesses or death in humans and marine life, including fish, seabirds, and marine mammals. Humans and animals can be exposed to algal toxins through the food they eat, the water they drink or swim in, or the air they breathe. Other algae harm ecosystems by smothering valuable habitats such as corals, or grow to such proportions that their subsequent decomposition depletes all life-giving oxygen in the water, thus killing most of the resident organisms. HAB events have been increasing in frequency and now affect all major regions in the U.S. and the Great Lakes to varying extents from year to year. The widespread occurrence and diversity of blooms challenges our ability to keep pace with the needs of coastal managers to protect human health and local economies. Reports just days ago of people being hospitalized in New England from eating tainted shellfish show how real these threats are. Our approach in NOAA to these problems are national in scope. They are targeted to the different regional needs, and they are relevant at the state level where managers are on the front lines and need new tools and knowledge to efficiently and effectively combat existing and emerging threats. Partnerships with state managers like Mr. Ayres and research scientists like Dr. Anderson, who will address you shortly, bring a wealth of expertise to our HAB programs and keep us focused on the management needs. Coordinating and collaborating between programs within NOAA and other federal agencies ensures broad engagement and efficient use of our resources in addressing these difficult problems. As our research programs yield valuable products, we are transferring this knowledge to operational programs in NOAA, as well as supporting the transfer and adoption of successful technologies to sustained operations at state agencies or other local or regional entities. We have a long record of accomplishments since the passage of Abarca in 1998 in virtually every coastal state, including improved HAB monitoring and detection capabilities, identification of methods to prevent the development of blooms, and forecasts to provide more efficient and comprehensive ways of assisting state managers and warning the public of potential exposure. I'll mention only 3 examples to provide a sense of the progress we have made together with our partners. NOAA has developed a satellite-based warning system for the devastating red tides in Florida, which you just heard about. This is the HAB bulletin that comes out twice a week and forecasts the progression of red tides and gives local managers a heads up. We're hoping to expand that system to Texas and then eventually go national with this system. A NOAA-funded monitoring system off Texas recently detected a rare HAB species which alerted state public health managers to this threat. shellfish harvesting was suspended and shellfish recall just days before the Fulton Oyster Fest, a major event in the region attended by thousands of people. Early detection and quick warning prevented human illness, which could have been a devastating blow to the local shellfish industry. The current severe red tide affecting New England states was predicted months in advance as a result of NOAA-funded research. The prediction and subsequent data being supplied in near real time is allowing state managers and the shellfish industry to deal effectively with this difficult situation. So in conclusion, over the last 10 years, we've made unprecedented progress in understanding the causes and consequences of harmful algal blooms, which has led to the development of numerous tools that are already in service and improving HAB management. We're working hard to build upon these successes by continuing to move newly developed technologies into application and operation at the national, regional, and state levels. And we also plan to spend additional effort with managers and other partners to identify critical future needs, region by region, and develop strategic plans to fill those gaps. Thank you for the opportunity to speak on behalf of NOAA on the topic of HABs, and I will be happy to answer any questions that you may have.
Thank you, Dr. Magnian. Dr. Anderson, you're recognized.
Mr. Chairman and members of the subcommittee, my name is Don Anderson, and I'm a senior scientist at the Woods Hole Oceanographic Institution, where I've studied red tides and HABs for over 30 years. I've also been actively involved in the formulation of the programs and legislation that support our national HAB program. And to reinforce what Rob Magnian just said, I'd like to go through some images here for you. HABs are caused by algae, many of them microscopic, as you see here. These species make their presence known through massive blooms of cells that discolor the water. This is sometimes through the illness and death of humans who have consumed contaminated shellfish or fish, through the mass mortalities of fish, seabirds, and marine mammals, and sometimes through irritating or aerosolized toxins that drive tourists from beaches. Seaweeds can also cause harm, as seen in these images from China, where the sailing events in the Olympics are threatened by massive blooms, and some rather spectacular images, I think. Marine HABs affect every coastal state in the United States. Now, Florida, Texas, and other states in the Gulf of Mexico are affected by HABs that make shellfish poisonous, that kill fish, and that release aerosolized toxins. The causative organisms can be found in the water year-round over wide areas. These cells proliferate in certain areas and at certain times, often offshore, and are then transported to shore by wind events. And special features of the ocean bottom facilitate this transport and focus cell delivery to sites of recurrent blooms, as you see here. And the studies are ongoing to address the highly controversial issue of the potential link between red tides and nutrient inputs from land, including those associated with agriculture and other human activities. Now, in contrast, in the northeastern United States, a different algal species produces toxins that accumulate in shellfish, but that does not cause massive fish kills or become aerosolized. These blooms show no obvious link to land-derived pollution. The organism is not present in the water year-round. Instead, the blooms are heavily reliant on a cyst or a seed stage that lies dormant in the sediments for most of the year and then germinates to inoculate the surface waters. So the blooms are highly seasonal. Here again, the transport pathways have been identified that are critical in carrying the toxic shells to both nearshore and offshore shellfish, as shown in this image. Industry efforts to open a $50 million a year sustainable offshore shellfish resource near Georges Bank are being severely constrained by the offshore component of these blooms. So in these and many other cases, research progress has been significant and is providing tools to managers. For example, a computer model of HAB dynamics in the Gulf of Maine has advanced to the level where we were able to forecast this spring a major bloom for the region that did occur several months later, an outbreak that closed shellfish beds from Canada to Massachusetts. This is the first time a forecast of this type has ever been attempted anywhere. This model is now being used to provide weekly forecasts to managers and will be used by NOAA as the basis of an operational HAB forecasting system for the Gulf of Maine. So research progress on HABs has been significant in the U.S., and in part because the scientific and management communities worked together 15 years ago to formulate a national plan or research agenda. The 1993 national plan is outdated, however. We therefore formulated a new plan called Harness, a framework that will guide the U.S. HAB research and monitoring well into the future, and I enthusiastically support this program. Now, under Harness, several existing national research programs will continue, but new programs are needed. And prominent among these is a program on prevention, control, and mitigation of harmful algal blooms. This is something that Rob Magnian described as the RDDTT program. I also endorse this program and recommend that funds be provided for it that are separate from existing fundamental research programs such as EcoHab. There are a number of promising HAB mitigation and control strategies under development that are highlighted in my written testimony. Perhaps we can explore during questions. So in conclusion, the diverse nature of HAB phenomena and the hydrodynamic and geographic variability associated with different outbreaks throughout the U.S. pose significant challenge, there's no doubt. As a result of research funding through EcoHab and other programs, however, the scientific and management community has the skills and the knowledge to deal with these issues and stands ready to partner with Congress and federal agencies in an expanded national HAB program that transitions science to practical applications. Mr. Chairman, this concludes my oral statement. Thank you for the opportunity to present my views.
Thank you, Dr. Anderson. Mr. Ayres, you are recognized now for 5 minutes.
Chairman and members of the subcommittee, thank you for the opportunity to speak today. I represent coastal fishery and human health managers not only from Washington State but also from around the nation who face the task of providing citizens with access to some of the most productive fish and shellfish resources while protecting those citizens from the threats posed by harmful algal blooms. I've spent a significant portion of my career working for the Washington State Department of Fish and Wildlife, managing a key shellfish fishery, the harvest of the Pacific razor clam. This abundant and very delicious shellfish species has long been a part of the lifeblood of the small communities that line Washington's Pacific coast. Over 250,000 avid razor clam harvesters are drawn to these small Washington towns during the periods when this fishery is open, bringing with them millions of dollars spent on lodging, food, gas, and entertainment. One local restaurant owner left me a message on my office phone saying that a recent morning razor clam opener meant an additional $8,000 in sales, important income for him and his employees. Then just last week, as I sat in a small restaurant in the Pacific County town of Long Beach, I overheard a conversation between a waiter and some out-of-town customers. He told them the only way the restaurant can survive the winter is the few days each month the state opens the razor clam fishery. In addition to the economic impact, one cannot overlook the significant role the ability to dig for razor clams plays in the lives of so many Washington residents. The joy of joining with family and friends to brave the elements to harvest these shellfish and then return home to prepare a big meal of fresh razor clams cannot be overlooked. These kinds of activities have gone on for generations for coastal families, and they are a big part of the social fabric of these communities. However, the opening of this fishery does not come cheaply to the state of Washington. Each monthly opener must be preceded by favorable results from work conducted both by my agency and the Washington Department of Health, sampling for harmful algal species and the testing for levels of toxin in clam tissue. Razor clams are also important to tribal communities, not only for subsistence but also for income generated by the sales of clams through commercial harvest conducted by the tribes. My agency works closely with the Quinault Indian Nation to jointly manage razor clams along a portion of the Washington coast, and we share the monitoring for harmful algae. But amidst all the good news about successful harvests and positive economic impacts on small communities is the very real threat of closures. As a result of significant increases in harmful algal species and the uptake of toxins by these tasty shellfish. These closures can be devastating events that have lasted up to a year or more. Closures heavily impact the citizens who count on these shellfish for a portion of their livelihood. Many other coastal managers from around this nation could tell you similar stories of how important our coastal resources are to the citizens of our nation and the devastating impacts HABs have had on the fabric of other U.S. coastal communities. Over the last several years, I've had the pleasure of getting to know many of these other coastal managers as we were brought together by NOAA to assist in the preparation of the National Plan for Harmful Algal Toxins and Harmful Algal Blooms, as Dr. Anderson referred to the Harness Plan. This document was made much stronger by bringing together federal and academic scientists and the state-level managers. The process was a unique opportunity for each of these groups to teach the other about their work, their struggles, and the goals they share. This process and the resulting plan have spawned other important endeavors, including the Harmful Algal Research and Response, a Human Dimension Strategy, which brought together key social scientists with HAB researchers and coastal managers to define and address the impacts HABs have on what I described earlier, the social fabric of the affected communities. A more recent NOAA-sponsored workshop brought together a larger group of HAB researchers and coastal managers from around the nation to provide input into the National Scientific Research, Development, Demonstration, and Technology Transfer Plan on reducing impacts from harmful algal blooms, the RIDIP plan that Dr. Magnian referred to. In Washington State, we've also followed this model by bringing together Northwest-based federal HAB researchers, University of Washington oceanographers and algal experts, state and tribal fishery managers, and human health experts to form a successful partnership, the Olympic Region Harmful Algal Bloom Project. Begun in 2000 with funds from NOAA's Monitoring and Event Response for HABs program, it is now solely funded by state dollars generated through a surcharge on shellfish licenses. Working together, we are doing what we can to monitor our shellfish and our waters to ensure the safe continuation of the state's important fisheries. Using the example of Washington's razor clam fishery, I hope I provided you with a better understanding of what our nation's ocean resources mean to the citizens of our small coastal communities. I hope you also see the impact HAB events have had on these communities and how important the continued involvement of the federal government in bringing the experts and the needed resources to the better understanding and perhaps in the future control of these events is to our state and local governments. And finally, I hope you see the value in using federal resources to continue to bring all the players, state, tribal, academic, and federal, to the table to jointly address the issues presented by the presence of harmful algae. Thank you again for the opportunity to be here today.
Thank you very much, Mr. Ayres. Dr. Hudnell, you're recognized for 5 minutes.
Good morning, and thank you for inviting me to testify about freshwater HABs. I am Dr. Hilton Kenneth Hudnell, and I served as a neurotoxicologist at the U.S. EPA for 23 years, where I led an interagency effort to address the freshwater HAB problem. I am now an adjunct professor at the University of North Carolina and vice president and director of science for SolarBee Incorporated. Today I will tell you about HAB cells and their toxins, the risks they pose for human health and ecosystem sustainability, the increasing occurrence and causes of freshwater HABs, approaches to preventing freshwater HABs, and the need for improved legislation to address HABs in all of our nation's waters. Freshwater HABs are primarily caused by cyanobacteria. Blooms are rapid expansion of cells to huge biomasses, often seen as surface gums or mats. Cyanobacteria have been around for 3 billion years. They developed the photosynthetic process and pumped oxygen into our atmosphere. But about 50 types make highly potent toxins, much more potent than industrial chemicals and about equally potent to cobra venom. Many make multiple toxins and many make the same toxins. The toxins affect the liver, nervous system, and other organs. The toxins threaten human health and the sustainability of our aquatic ecosystems. Unfortunately, we are making the earth a better place for them to live. The frequency of freshwater HABs is increasing rapidly. There are no regulations or guidelines for freshwater HABs. The EPA has not assessed the risk or developed a national research plan for freshwater HABs. The World Health Organization and some countries have developed regulations and guidelines. States and local governments are left without federal guidance. Humans are exposed to HAB toxins in drinking and recreational waters. There is no affordable method for removing all HAB toxins from drinking water. HAB toxins are causing acute, chronic, and delayed health effects. Acute effects range from rapid death to severe gastrointestinal and flu-like illness. Some people remain chronically ill. Science indicates that repeated exposures cause cancers and probably neurodegenerative diseases like Alzheimer's. All levels of aquatic life suffer lethal and sublethal effects from HAB toxins. When HABs die off, they sink to the bottom and use up all the oxygen. Millions of fish die annually due to lack of oxygen. Scientists and water managers know the incidence of freshwater HABs is increasing rapidly in the U.S. and worldwide. Each year, HABs occur where they had not occurred before and for longer durations. HABs require nutrients, sunlight, warmth, and calm water. HABs are increasing because too many nutrients are going into our freshwaters, increasing temperatures and decreasing flow rates. The nutrients come from point sources like wastewater treatment plants and non-point sources like fertilizer runoff from our yards and farms. Water flow rates are dropping as demand increases and droughts are more frequent. Climate change is exacerbating the problem. Costs in the U.S. are estimated to be many millions of dollars per year. We can only target HAB causes of nutrient input and calm water. Nutrient usage should be reduced and nutrients should be recaptured and reused. Water flow rates cannot usually be increased. However, water can be circulated. I joined SolarBee because I believe they make the best technology for moving water cheaply. Floating platforms powered by solar cells circulate water over long distances continuously. HABs are prevented over a 35-acre area per unit with a success rate of 95%. Algicide usage to terminate HABs is dangerous for humans and causes long-term damage to aquatic ecosystems. Abarca led to a national research plan for HABs in oceans, estuaries, and the Great Lakes. Funds authorized through Commerce to NOAA support competitive HAB research grants. EPA funding was not authorized, but EPA was statutorily required to help produce a scientific assessment of freshwater HABs and a plan for a national research program to mitigate and control freshwater HABs. I helped prepare those documents. However, the EPA then unilaterally determined that its statutory requirements were completed. There is no agency effort to develop or implement a national research program for freshwater HABs. The agency ceased virtually all participation in freshwater HAB research and mitigation. The EPA quit funding the interagency extramural HAB research grant programs and ceased all HAB research in its National Health and Environmental Effects Research Laboratory. Congress should pass a freshwater Abarca legislation that authorizes funding for and requires the EPA to develop and implement a national research program for freshwater HABs. The agency should be directed to form partnerships through a strong extramural, peer-reviewed, competitive research grant program open to all private and public, for-profit and nonprofit organizations. Funding should be directed to the existing interagency grants programs and the newly proposed RDD-TT program for HAB control technologies. Legislation will provide clarity to the EPA that freshwater HAB research is authorized and required. Congress should then appropriate funds for freshwater HAB research. I would urge the House Science and Technology Committee, which has primary jurisdiction over EPA research, to develop and advance a national freshwater HAB research bill. I am pleased to offer my expertise to help develop such authority for the EPA. I thank the subcommittee for allowing me to express my views today.
Well, thank you very much, and thank all of you for your testimony. At this point, we'll begin our first round of questioning, and the chair will recognize himself for the first 5 minutes. Dr. Magnian, before we get into the discussion on how to move forward on the issue, I want to ask a question about the last Abarca reauthorization in 2004. There were a number of reports and plans that were supposed to be done within a year or two of enactment. I've only seen one transmitted to Congress. Can you tell me about the status of each of these reports, why it's taken so long to produce them? I'm referring specifically to the research, development, demonstration, and technology transfer plan, the 3 assessments of harmful algal blooms, freshwater harmful algal blooms, and hypoxia.
Right. As you mentioned, there are 4 reports. The 2004 authorization, 1 has been produced, and the 3 others are essentially completed. They're just going through the final stages of review and will be transmitted to Congress shortly. Part of the challenge in putting those together was to fully engage both the research community, the management community, and the federal agencies in coming to consensus on these reports. So I think the product, even though it is a little bit beyond the deadlines, is well worth the extra effort, and we made all attempts to keep Congress informed throughout the process of some of the delays that were occurring.
NOAA leads 2 important competitive research programs, the EcoHab and MERHAB programs. These programs got off to a very good start in funding many projects that have contributed to the advancement of knowledge and management capabilities that we have now. Are there any new solicitations for these programs to continue these?
We had a competition in this fiscal year for the EcoHab program. We alternate between years between the EcoHab and the MerHab program. Unfortunately, our funding availability this year would not allow us to start any new awards for the '08 competition, although we did provide funding from some of the multi-year awards for past competitions.
Thanks. Dr. Anderson, you mentioned that the current national plan is outdated, and now we have the new plan harness to help address the issue for the next decade or more. What specific components of this plan should be incorporated into the next Abarca reauthorization?
Well, Mr. Chairman, you've heard us mention several possible programs. One that keeps coming up is this RDDTT, or a better way to think of it perhaps is Prevention, Control, and Mitigation of HABs. And the way that report has been written, and I in fact have appended the executive summary of that report to my written testimony, it has three components to it. One is an actual research and demonstration program on prevention and control mitigation strategies. But then there's also an event response element and then an infrastructure element. And without going into great details, each of those is needed because we need programs that will help us test and demonstrate mitigation and control strategies and practical science, bringing science through to practical applications. But we also need to help the states and the regions respond with these massive outbreaks and unexpected outbreaks, so an event response element is needed. And then we also need what we're calling infrastructure, which means toxin standards for all the measurements that are needed, and culture collections, and many, many other things that we need to conduct our research that everybody shares. That's an infrastructure element. So we've put all of that under this RDDTT umbrella. So that's one program that I think really is needed, and as I said, it needs to be separate from the, and shouldn't steal funds or shouldn't take funds away from the basic research that's already there with EcoHab and MerHab.
What are the major research gaps and obstacles? And I guess you spoke some of that, but that are making make predicting the occurrences of the harmful algal blooms difficult. And are there other technologies that we could be using to help make better predictions?
One of the, I'll use my own region as a perfect example. We have developed what is probably one of the best numerical models in the world for harmful algal blooms, and it's the one that allowed us to make predictions, that we give forecasts to our managers, but at the same time it is restricted by our ability to collect data during these outbreaks. You get very good weather forecasts because there's a continual flow of data from sensors and weather stations everywhere that's being used to constantly update your weather models. We don't have that in our system. So what we need, as one answer to your question, the Ocean Observatory system is starting to instrument the coastal ocean. What we need are instruments as part of that system that will detect HABs and their toxins and relay that information to us so that we can assimilate it into our models and improve those forecasts and predictions. To me, that's a very, very important step forward.
Can we do it with satellites?
Satellites will only work in some parts of the country with certain HABs. Like in Florida, satellites work very well in their predictive system that Dr. Rob Magnian mentioned. In the Northeast, for example, or in the Northwest, our blooms are never dense enough, or rarely dense enough, to be visible from space. So satellites are only useful in some locations.
Mr. Ayres, Dr. Hudnell, would you like to comment on that?
I definitely support what Dr. Anderson said. There is a great need to give a window of opportunity to risk managers to take action before harm is done. The better we can develop models, like Dr. Anderson has, to predict when these events will occur, the better we can protect the public health from these very potent toxins.
The only thing I might add is I did spend some time working on the event response portion of the RDT workshop report. RDD, however that goes. And event response really is important to state managers, and the ability to share resources between states and be able to have federal experts come quickly to the aid of states in the event of these blooms that occur quite quickly is terribly important to state managers like myself around the nation. So,
Mr. Inglis, you are recognized for 5 minutes.
Thank you, Mr. Chairman. Dr. Magnin, understand that there's some question about the capacities of the INPOS satellite to see as well as or get images as good as we're getting now. Is that your understanding as well, or?
Well, I'm afraid I'm not a satellite expert, so I really wouldn't be able to comment on the specifics of that satellite technology, but I'd be happy to provide that information following the hearing.
It would be helpful because it's of concern if INPOS isn't going to get us as good of pictures as we're getting now. And does anybody else have anything to say about that, or any information about what that?
I can't comment specifically other than that I have been to several meetings where the members of our community that do work with remote sensing information have spoken very strongly about the need for some strong guidance to the government to improve the next missions that go out, the instruments that are going up there, because we are reliant, as I understand it, on an Indian satellite that will be coming up that we don't even know will have the correct wavelength, the correct information that we've been getting, or satellites that already belong there beyond their design life. And so the next 5 or 10 years is sort of a black hole for some of these sensors up in space, and so I have heard that there is a genuine concern, and that's perhaps what you're also referring to.
And speaking of images, Dr. Anderson, I think it's you that had particularly, as you said, dramatic images from China. Is that, is what's going on there typical as to what we see elsewhere, or is this particularly unusual amount of growth?
They truly are dramatic images. The answer really is that in some parts of the world that is, I won't quite call it typical, but in many developing parts of the world where there is a strong input of pollutants into coastal waters, this is the type of event that you can see. China has, unfortunately, over many years, focused a lot of energy on feeding its population, on with agriculture and aquaculture in the coastal zone, and you're now seeing the effects of that. There's no question that those seaweed blooms are being driven by pollution, much heavier pollution than we typically have in this country, so we don't see some of those types of events in that extreme. But down in Florida, for example, there are seaweeds washing up on beaches and rotting and decaying that occurs up in the New England area as well. It just is not quite as extensive.
Maybe a question better directed to the chairman, because I think he's had some business experience with this. But we could learn something from these rapid algae blooms, right? In using CO2 to grow this algae into biodiesel, right? There's sort of a twofer. Should recognize the chairman to speak on that. I don't know, but maybe you want to speak about that. That there is it's sort of a twofer to figure out how to prevent it from happening in the ocean, but maybe have it happen. Rapid growth where we want it, so we can harvest that material, right? Is that?
I'll offer a comment there. We all get comments and questions these days from industry and so forth about exactly that. Couldn't we harvest these blooms and turn them into biofuel? And the answer is that the economics aren't really there for most of them, and especially given that not all of these blooms are as spectacular as some of the pictures you're seeing, and you need to have a sustainable resource. But there's no question that if you move this whole process on land and develop the ability to grow these mass quantities of algae, they are a much better approach to biofuel than growing corn and going the ethanol route. You can grow them in desert locations. There's many advantages to using algae for biofuel. But I don't think one can do that with natural blooms. I think they're too sporadic, and in many cases, actually, the harm we get is from very dilute suspensions of cells that would not be suitable for biofuel.
My time is up, Mr. Chairman. Thank you.
Wondering if we couldn't create some giant vacuum cleaner and suck all this stuff up and filter out the algae, squeeze the oil out of it, and make fuel. Apparently, that's not the best idea in the world. Mr. Baird, you are recognized for 5 minutes.
Thank the chairman, thank our witnesses. This is indeed an important topic, as mentioned earlier by my colleagues, and mentioned affects not only our Puget Sound and our offshore environment, also Vancouver Lake, right near my own home. One of the interesting things, Mr. Chairman, about the amnesic form of this is how it functions, and it would scare the willies out if you understand it. It attacks the hippocampus. I'm a neuropsychologist by training, and the hippocampus is the structure of the brain that's responsible for basically transforming current experience into long-term memories. And when the hippocampus is bilaterally lesioned, you get a phenomenon wherein you have your old-term memory, your long-term memory, but nothing gets in. So if we left the room and came back a couple minutes later, you would not remember that we'd seen one another. Sometimes Congress seems to have suffered from of this, but it is really quite astonishing and highlights the seriousness of this. You know, it's not just about closing our shellfish industry. It's about a permanent, severe neurological impairment that results, and that's why this topic is so important. I would caution, by the way, the notion of commercial algal use for petroleum production. It's just an article in Science, I think, last week about a reef structure in India that's been devastated by the release of algae apparently used for commercial production purposes, and is just flooding over this reef, and you should see the pictures. They've been wiped out. But I want to get to the question of what do we do about these things? I think you've talked about the monitoring. It sounded like, Mr. Hudnell, that there are some approaches to actually reduce. I mean, you know, once you've got a bloom, these things are pretty intractable. What do we know about how to get rid of them once they're there, especially in relatively small, closed water environments? I know a big bloom off a coast might be hard, but what are our spectrum of opportunities for this?
Yes, well, speaking for cyanobacteria in freshwater blooms, and somewhat it pertains to the red tides also, there are 4 requirements for blooms. They need nutrients, particularly phosphorus and nitrogen, as well as trace elements. They need sunlight for photosynthesis. They need warmth. Many of these developed in warmer areas south, and they move north as temperatures increase. And they need quiescent, stagnant water. So when you're talking about solutions for control, you look at the causes. You can do something about nutrients. You can reduce nutrient input into our water. We need to do that for many reasons. Not only the HABs and water quality, but we need to reduce nutrient input because phosphorus, we're predicted to peak production in 30 years and be out of resources for phosphorus in 50 to 100 years. We need to be recapturing and reusing these instead of let them run into the water and cause problems. We can't do much about warmth and sunlight, but we can do something about quiescent, stagnant water. Unfortunately, we can't usually just open the floodgates and lot of water rush out because of increasing demand and droughts, but we can circulate the water. That's why I went to work for SolarBee, because they made solar-powered floating platforms that are solar-powered with a battery, high-efficiency pumps. You put a big hose down, you draw in water horizontally from long distances. Water is in different density layers, so you draw in from one layer at long distances, bring it up at 10,000 gallons per minute, and push it out smoothly on the surface to circulate the water over a 35-acre area. And it's strong enough circulation to prevent these HABs over a 35-acre area per unit. So the effect is additive. The more units you put in, the more area you can protect. And for example, now we have about 20-some circulators protecting the water intake in Houston in their reservoir, which has had bad HAB problems. And so I think that we should combine our efforts to do 2 things. Control nutrient input to water through best management practices, reduce the amount of nutrients we use. For example, there are bills now to take phosphate out of detergents. We should do some of that. Find other ways to use only what we really need, not just throw all the fertilizer out and you think the more the better. And We need to recapture the nutrients at the point sources where they come out of the pipes into the water. There can be systems there that precipitate out the phosphorus before it goes into the fresh waters. Then we can take it and reuse it. And we need to combine that approach of nutrient input reduction with the circulation of water where just there's no other means for it to be anything other than quiescent and stagnant. We need to keep it moving. And we're doing research now to figure out why that works. We know it works, but we haven't done the research yet to figure out how it works. So that's my approach to HAB prevention and control.
To bring this to the marine side of the story, we do have a number of technologies that we are looking into. Some of them are very, very simple. In Korea and other countries in Asia, they spray clay over the ocean, and it flocculates. It makes larger particles, carries these red tide cells to the bottom, and they've effectively protected their fish farming industry with a modest investment compared to the value of that industry. Interestingly, though, and my lab's been actually doing work on that, we have encountered quite a bit of environmental opposition to this, as you might understand, but at the same time, it's rather frustrating from my standpoint, because we do everything I think we need to do to demonstrate that this is much less damaging than the red tide itself, and that clay flows into the ocean constantly from rivers and so forth, and yet there is this, there are groups that oppose it. And so what's happening is we're developing certain technologies, and I could mention viruses and parasites and bacteria that will all destroy these red tide cells. But there's a social issue that we need to address, and to get a society to accept this in the ocean is going to be a big step. We already accept spraying for mosquitoes, spraying for pests on broccoli or corn or whatever, but people are not yet ready to let us do the same in the ocean. And I think this is an important area for this topic. It's an important area for invasive species as well. And it's one that I think we can approach, and that's one of the reasons that I think we need this separate RDD-TT program, because when I write a proposal that tries to get funding for clay work and it's competing against basic science proposals from other investigators, guess which ones tend to get supported? Because mine is much more controversial. I can get easily people who say it's never going to work, it's going to cause all these problems. And so you need to have a separate pool of money where engineers and everyone else comes in and starts to attack these problems while the basic research keeps moving.
Mr. Chairman, I just would, I know my time's up, but I'd be very interested in following up with you on that, Dr. Anderson. We've seen this with invasives in my own district, where an invasive species threatened to wipe out a marine estuary, just was going to destroy it, turn it into a prairie from an estuary. And the fight was to get an herbicide labeled so that we could kill, it was Spartina grass, and we almost lost the estuary. We're beating it now in a remarkable success story, but we need at some point to gauge the cost benefits in a better way, and just saying under no circumstances intervene when the condition that you're trying to beat may be far more destructive than the intervention, and finding a way to deal with that would be very helpful. Maybe we could pursue this in this committee. Thanks, Dr. Anderson. Thanks for
Thank you, Mr. Beard. Mr. McNerney, you are.
Thank you, Mr. Chairman. I think I'm going to say the same thing that Mr. Beard said. This is a fascinating subject, and I don't know that much about it, so thank you for coming and testifying. Dr. Anderson, could you outline briefly, or in detail if you wish, what you think the impact of climate change and specifically ocean acidification would be on HABs?
I'll take the marine side of that, and I think Dr. Hudnell will probably have some comments to add about the freshwater side. We were asked that question a lot, and it is a very difficult one to answer, because these are very complex phenomena. And in my own region, again, I'll use that as an example, we now have computer models for future climate scenarios that would say we will have more rainfall and longer, warmer temperatures and things like this. And we can start to put that into our models about what that might do to our blooms. But these organisms are very adaptive. As I said, these have a cyst stage that remains in the sediment. It's a lot like a seed of a higher plant. So if the winter is shorter, it just means it will germinate a little bit earlier. And if it's a hotter summer, it may end its bloom sooner. So it's very hard to say how much difference that would make. But I think in general, we could say that we are going to see a movement of these problems from some areas where they occur now into other areas where they don't, just because temperatures become more tolerant. But on the other hand, you might actually see the disappearance of some of them from some areas as the temperatures become too warm, for example. Acidification is an issue that I don't have any specific answer with all of our different HAB organisms. There are so many different kinds that each one would have to be studied separately, and that research is just beginning. I think that on the freshwater side of the picture, though, it's a little more clear that with the warming temperatures and the changes of even the pH, that one would see more of the cyanobacterial blooms.
Yes, I believe that climate change is having an impact on this and will continue to do so. First of all, the issue of increasing temperatures. We're seeing organisms that used to only occur south of the United States occurring in the United States now and spreading rapidly. For example, Cylindrospermopsis, which makes highly potent cylindrospermopsin toxins that affect multiple organ systems, stop protein production. This is occurring at many places in this country now and expanding because of it's getting the warmth that it needs. But on top of temperature, the precipitation and storms is another issue. It's sort of ironic that with climate change, it seems that you get, on the one hand, more frequent heavy storms. And what this does is wash off more nutrients into our fresh water. But on the other hand, you also get more frequent and extended drought periods. And so when you get droughts, you get slower water flow, more quiescent stagnant water. So both of these factors tend to increase the occurrence of these freshwater harmful algal blooms.
Thank you, Dr. Maniam. You mentioned, or you went over the predictions of the New England event. How effective would that modeling be in terms of other types of these events around the coast, other coastlines, other sections of our coastline?
Well, that's a good question because it speaks to the national scope of our programs as well as tailoring things regionally. So there definitely are components of all of these types of research, whether it's a forecast or a detection or a control issue with a virus or a bacteria or clay, that is transferable from one region to another. So the knowledge that we've developed through our partners in New England can definitely be transferred elsewhere, not necessarily lock, stock, and barrel, but with adjustments to the particular HAB species or the circulation patterns in a given region with much less effort and shorter time frames. So we're looking at all of those opportunities to get efficiencies and transfer knowledge from one region to another, and we've already got a number of very good examples where that's been done.
So is it coordination, do you find the coordination between agencies or scientists to be at a beneficial state now or a non-beneficial state?
No, I think it's at a beneficial state, and we're working very hard in NOAA to help support that. And you've heard a number of our efforts to support that through workshops, through the Harness Report, which we provided funding for. We've had workshops in Florida recently. We're going to have another workshop on the regional problems in the West Coast. We've gotten great participation from the managers, the social scientists, the federal agencies, and we're also working very hard with all of these groups in putting together the reports for the Abarca legislation that the chairman asked me about earlier, and that's a big job, but it's one worth taking on and doing to the benefit of everybody.
Thank you. My time's expired, but would you let Mr. Anderson have a word?
Just to add to the issue of the transferability of the model results, since it was our model that was doing this prediction, there's right now these models have generally two components: a physical model, which is of the circulation of the water, and those are being developed all over the country, and into those we have to build the biology of these HAB organisms. And many of the HAB organisms that we work on do occur in other parts of the country. So the one that causes problems in New England also occurs along the coast of California and Washington and even Alaska. So I actually have received inquiries and inviting someone from Washington to my lab to do some of the experiments that are needed to take their organism and to just change the parameters slightly so that they can use that modeling. So in many cases, I think these modeling efforts are transferable with some tweaking of the organism so that it reflects this region as opposed to that region.
Thank you, Mr. Chairman.
You're welcome, Mr. McNerney. Thank you. Mr. Aiken, you are recognized for 5 minutes.
Thank you, Mr. Chairman. And so we've got 3 hearings all at the same time. It's hard to be in 3 places at once, but and so I missed your testimonies. First question I have is the problem of fertilizer runoff and things like that off of land, particularly farmland, has long been a problem. I think of it more in connection with Lake Erie and freshwater bodies more than saltwater, perhaps. And then there's also talk, though, about conditions in the ocean where there's some pH change. It's not driven by fertilizer, I think, as much as it is pH change, which then tends to destroy coral formations and things like that. Are these in any way connected, or are they 2 totally separate situations, and which is more serious?
I assume you're talking about actually 3 things here: the nutrient connection to harmful algal blooms, but also the ocean acidification connection to harmful algal blooms. I think before you walked in, Dr. Anderson addressed some of the issues related to the ocean acidification, and that it's so early in the research phase there that we really don't know how that particular situation is going to affect the multitude of different species that compose the group of harmful algae. The nutrient...
Do we know for sure that it is a pH thing that's driving those conditions?
pH is involved, but nutrients are much more overwhelming in importance for harmful algal blooms.
So if you say the drivers, you're saying we know for sure the nutrients is a huge part of it.
Right.
The pH is not as clear cut.
Exactly. And the changes we're seeing, at least now, in pH are fairly subtle. So it may become an issue down the road, and we certainly should look at that. But for now, the immediate issue is nutrients. And
is it nitrogen or phosphorus? Or what?
It can be both. In marine systems, it tends to be more nitrogen, but phosphorus could be involved. In the freshwater situations, it tends to be more phosphorus that kick up these large blue-green algae blooms in freshwaters. And it also connects with another important issue in Abarca, which is the dissolved oxygen or hypoxia problem. So all these things are interrelated, and that's why we...
Well, these reduce the oxygen in the water, don't they, the algae?
Right. Well, it's you have a sequence of events where the excess nutrients pouring into these water bodies create an overabundance of algae. They eventually die, decompose, settle to the bottom, and in the decomposition process, they use up the oxygen, leading to fish kills and loss of habitat. And that's one of the reasons why you've heard so much about predictions here. We try to put all this complex science together in models and in a way that managers can make decisions. You know, if we can't just wave our arms and say nutrient pollution is a problem, we need to be specific and say, you know, if you reduce it X percentage, this is how it's going to affect the algal blooms.
Now, with the new GPS and farming, certainly the farmers have an incentive, increasingly an incentive, to be sparing with their fertilizers.
Right.
So with the new GPS systems where you're literally putting just the fertilizer in you need, has that become pretty effective in knocking it down from where it was 10 or 20 years ago?
Well, it's certainly helping but we've still got a huge issue there. And actually, NOAA has been talking recently with USDA to try to work with them and address this nutrient problem, as well as with EPA and other state and federal agencies that can influence the situation.
Could you comment on the change? I mean, if you take, for instance, clean air, I'm from the St. Louis area. If you take a look at the air that I was breathing as a high school student, which I thought was pretty good air, I didn't have much other alternative but to breathe it. But if you take a look at that air by today's standards, I mean, it's orders of magnitude cleaner than it was when I was in high school. Do we have the same kinds of improvements? Because this is a problem that's been around for a long time.
I would say we have comparable improvements on what we call the point sources of nutrient pollution, such as wastewater treatment plant and industries. We've done yeoman's work there just here in the Potomac River. Some of those images that we saw earlier, the green paint type covering of the water, used to be here, right here in the Potomac in the 60s and 70s, and due to the wastewater treatment at Blue Plains and other big treatment plants, that's made a remarkable recovery comparable to the air issues. Where we're still struggling is what we call the non-point sources, which are primarily agriculture runoff from urban areas. It's much more difficult. It's much more pervasive. It's not an engineering fix at a particular pipe. So we need to continue to be vigilant there and work with new technologies and methodologies to help reduce that problem.
Mr. Chairman, I know that my time has expired, but I thank you for your patience and thank you for appearing, all of you, as our witnesses.
Thank you for your good questions. The chairman will recognize himself for 5 minutes. Mr. Ayres, as a coastal fisheries manager, what NOAA projects and efforts are most helpful to you in dealing with the impacts of harmful algal blooms? What could this program provide that would be more helpful in the management decision-making process?
A recently completed, or nearly completed, EcoHab-funded study of the movement of Pseudonychia, the plankton species that causes the problems most significant on the Washington coast, has provided us a lot of detail about how that happens, and has given us much better insight into how those plankton species move and when we might expect problems with the shellfish that we're managing along the Washington coast. I mean, as Dr. Anderson pointed out earlier, continued data collecting is so important to that, and the federal funding is ended to this specific research. We have an understanding of how that works, but still continued visits to the area offshore, the offshore sampling that the state does not have the capability of funding, needs to occur in some way. And Dr. Anderson talked about ocean observing systems being a possible way of doing that, whether it's opportunistic ride-alongs on NOAA vessels. We have some staff out this week on a NOAA vessel offshore, just in an opportunistic way, collecting some samples in this specific area, the Strait of Juan de Fuca eddy. It's a region at the mouth of the Strait of Juan de Fuca where these plankton species tend to congregate and bloom and then eventually perhaps move on to the Washington coast. We also are affected by blooms that come from the south part of our coast and that also affect the Oregon coast, widespread areas. And there was an EcoHab proposal that was identified for funding, and as Dr. Magnian pointed out earlier, there wasn't enough funding to actually allow that to go forward, at least during this fiscal year, and hopefully it'll happen in the future. So additional work like that, EcoHab, large studies over these large ocean areas that it can identify not only the oceanography, but the specifics of what's happening, how these plankton species move on shore, or be very helpful to managers like myself in Washington and Oregon and down into California. We're talking wide areas. And, you know, we have a transboundary area as well where a lot of these blooms are coming out of the Canadian waters and affecting Canadian waters the same as they do in the U.S. So continued cooperation with researchers in Canada is certainly important as well. We do a lot of work with Canadians on a lot of issues because of that transboundary issue in Washington State. So the continued collection of just primary data and then the larger scale projects like EcoHab can fund is very important to managers like myself, especially in the Pacific Northwest.
From a manager's perspective, does the new plan that the research community has published, the Harness Plan, address the needed priorities and help in the prediction?
Yes. Harness did a very good job of doing that, and I think a very good job not only for a manager like myself in the Pacific Northwest, but for managers all around the country. And that's because, and I give NOAA a lot of credit for bringing managers into that process. And not only fishery managers, but human health managers early on. And so we had an opportunity to provide a lot of input. And if you look at Harness, you'll see comments by managers like myself throughout the document, pointing out what's important to us. And Harness did a very good job of that. And the RDDTTT plan did the same thing. And it was a great opportunity for managers to be a part of that process in a workshop format where we were able to provide a lot of input and then into that workshop plan that will eventually then influence the actual.
Can we improve it? And Dr. Anderson, would you also comment after Mr. Ayres?
Pardon me?
Are there any ways to make it, can the plan be improved?
Funding. funding, yeah.
Story of our life.
Yeah, I think that's the primary answer.
Okay. You make any comment, Dr. Anderson?
Well, funding is always the answer, but one of the ways to make that happen is partnerships among federal agencies, and we could use the help of committees like this to forge some of those partnerships. There are many agencies that have mandates where harmful algal blooms are involved in some level, and that are, in fact, a number of them are not participating in this national program. I could name a few: Department of Agriculture, for example, or EPA in some ways on the marine side in particular. So, if we could form partnerships and get some of these agencies to put their resources, even limited, then together we start to have the successes. EcoHab is a success in large part because it is a partnership. And as NOAA, NSF, or for a while NSF, EPA was in it for a while, the Office of Naval Research, and even NASA. So it was a partnership of agencies that would all jointly fund projects. So to me, that would be one of the areas where we could get some help.
I'll ask questions for Dr. Hudnell. What are some of the possible options for addressing the freshwater hebs? Research needed to understand freshwater hebs, much like what is needed for the marine and coastal hebs issue.
In my opinion, I believe it's very likely that nutrients are an issue both for freshwater and marine hebs. As we have heavy rainfalls, nutrients run off the non-point sources, which are harder to control, and they enter the freshwater and they flow to the coast. And the water is all connected. So you have, first of all, the nutrients starting hebs in the freshwater. They move down to estuaries. In estuaries, you may have the same species, same types of cyanobacteria or other organisms, but then you also can pick up new organisms that thrive better in that little higher salinity range. And then I think it's likely that this issue about marine hebs and nutrients, I just believe that all organisms require nutrients, and that if more nutrients are coming in, it's going to further stimulate it. And it may not cause the marine hebs to start, but it may, I believe, feed them and make them worse. The nutrient input reduction is critical, I believe, for controlling hebs, for addressing other water quality problems, and we should make a better attempt to control the input into the freshwater where it all starts. Second of all, in freshwater, particularly, we can circulate water where we know that it's too stagnant, where there are dams built, for example, new reservoirs put in. We're building lots of new reservoirs. 2/3 of our population now get their drinking water from surface water. As our aquifers are becoming depleted, we're building more and more of these. And unfortunately, we tend to have more and more situations where the water is too stagnant, too quiescent, and that's causing blooms to happen. And if you look at a place like the Klamath River that starts in Oregon and moves through California down to recent years, the problem there has just become phenomenal with species or genera of microcystis called, or cyanobacteria called microcystis. And it often starts with some problems in the upper portions of the river, but then when you get to the reservoirs where there have been dams built, you start to see these massive blooms of cyanobacteria occurring there. And It's because the water is so stagnant. And there we have seen the highest cell counts I've ever seen anywhere in the world and the highest toxin levels, many thousands of times above the WHO guideline level for what is a safe level. Very dangerous situation. And what happens is that these dams will open up and let water out. And last year, for the first time, there were so many cells that enough survived that they kept moving down the river. And they would be in one reservoir, move down, be in the next reservoir. And one of the slides I had flashing by showed them hitting the ocean. And it was just all over the delta. So it's a problem of both nutrients and cells moving down the water. And best, in my opinion, the best thing we can do, particularly in sensitive areas like shellfish beds, is circulate water in estuaries and places where it is too stagnant and prevent the nutrients from getting there to feed those HABs.
Do any of your the equipment that you mentioned earlier that you have down in Houston, have they tried that in larger, or have you tried it in larger open bodies of water like a bay?
We have just begun to do some of that. Some of these lakes are, more than 100 square miles. We're now starting to work in Lake Taihu in China, which is the second largest lake, I forget, but hundreds of square miles big, and they have terrible microcystis blooms every year. In fact, last summer, the town of Woozy, of several million people, they had to shut down all the drinking water plants because there was so much toxin in the water. So people survived off of bottled water for weeks until the situation.
Thank you very much, Mr. Inglis.
Thank you, Mr. Chairman. Dr. Hudnell, you were mentioning earlier the possibility of removing phosphorus from discharge. What are the economics of that? I take it not very good, and that's why it's not being done right now, or can they be somewhat positive?
There's not been research on that near enough, and there are no places to apply for research for funds for that kind of research that I know of. But at SolarBee, we've recently begun to look at this issue and trying different approaches. But what we're trying now is where you have this floating platform pumping up all this water, to put a metal ring around the water where it's coming into the unit and run solar-powered electric charges that pulse positive and negative off this thing. And what you can do is magnetize the phosphorus and attract it to these bars. And so if you can develop a system that will attract the phosphorus in, and then you can go and periodically exchange the rings, you can take all the phosphorus off those metal rings and use it. And this is just a very small scale first attempt to do this, but I think that potentially technology will allow us to do very large scale things like this at water treatment plants, for example, and recapture that phosphorus. And we really have no alternative in the future, because the phosphorus is going to be depleted, and we cannot farm without phosphorus. There's no synthetic alternative. Every living organism requires phosphorus, but we're using up all of the natural reservoirs of phosphorus that we now mine. And like I said before, production is predicted to peak in 30 years and the sources be depleted in 50 to 100 years. So there are many reasons that this technology needs to be, research needs to invest in this type of technology to look at how to best recapture on a economical way these nutrients that we are going to need for use in the future, and we need now to prevent from getting.
Yeah. Dr. Anderson, you had?
If I could just add to that, I want to make sure that we have it clear that only some of the HABs that we deal with, both marine and freshwater, are related to nutrient pollution, certainly more so on the freshwater side. But many of the problems around this country are if there's a nutrient impact, it's sometimes subtle. And so when we try to move forward with policies and programs, we have to look beyond just saying the problem is nutrients. So I just need to make that clear. And so that there are other technologies that we need to help manage those problems, whether it be predictions and detection systems and maybe even some efforts for bloom suppression that are not using nutrient as a preventative tool, but in fact going after the cells themselves with chemicals or parasites or something else like that. But I just want to make sure that the committee doesn't get the impression that the answer is nutrient reduction for all of these HABs.
What could be the other, just to recap that, the other possibilities are a natural phenomenon that's occurring, is that right?
Yes.
And perhaps some other variables. What would those be?
Well, again, let's go to my region. We've looked very hard. We have not found a nutrient relation with the Northeast paralytic shellfish poisoning problem. So if you're trying to manage that problem or do something about it, you're not going to change the river outflows or the way the wind blows and the types of storms we get. So the best you can do then is to be able to understand the system, to predict it, to forecast it, so the shell fishermen and the industries and so forth are aware of what's coming, and you develop better technologies to detect these cells so that you know exactly which areas should be closed and which should be open. You can in a sense start having surgical closures of harvesting. Instead of closing an entire coastline, you close here and there, but not over there. And so you have to live with the fact that these are natural phenomena and learn how to manage around them. And in that case, that's plain management. There's other areas, though, where we've talked about the technologies that can be used to suppress a bloom or control a bloom. That's what everyone keeps asking. If you can control mosquitoes, why can't you control a red tide? And it's a complex answer to that, but there are technologies there. I've mentioned the clay, I've mentioned viruses, parasites, and so forth. They all need more research, they all need pilot studies, and then some actual demonstration projects to show whether they will or will not work, and then we can perhaps get society to start to accept them. I mean, I will just say the same thing. Imagine your estuary, the Puget Sound's about to be invaded by some major organism that's going to destroy who knows what, salmon or something like that. Right now, I don't think we have the knowledge or the mandate, a government agency mandate, to be able to go out and stop that invader, and we have those same problems for HABs. And I think that something needs to change to help us fight that battle.
Thank you. Thank you, Mr. Chairman.
Baird, you are recognized for 5 minutes.
Mr. Chairman, I would say that one of the reasons I particularly enjoy this committee is we get to address issues that are not political radar screen, but may actually be very profound, both economically and from a health perspective. I want to just ask a clarification or edification for myself. The toxins that are produced from some of these HABs, my understanding is they're not, when we look at our normal water filtration and treatment systems, my understanding is some of these toxins are not filtered out. In other words, if I were a hiker going to a lake that had a HAB in it, I might get my usual filter out and think, oh, I'm thinking I'm going to get out, Giardia or something like that. But the toxins themselves can still be toxic even with normal filtration. Is that accurate?
Well, I can speak directly to the freshwater cyanobacterial toxins, and that, in fact, is one of the things that worries me the very most. There's a lot of data from Florida, for example, that shows if you repeatedly measure toxin levels in the raw source water and in the finished drinking water, many times you'll find the toxin levels to be higher in the finished drinking water than in the raw source water. The reason that occurs is because when you bring in water to the plant, one of the first things you do is filter it. And you filter it, that lyses or breaks open the cells. And then the cells release all their toxin into the water. And normal drinking water processing, is shown by the Florida data, just does not get these toxins out. And I've looked a lot into this issue with one of my colleagues who specializes in this, Judy Westrick, and other people. And what you find when you do laboratory tests is that even if you take only one toxin, one cyanotoxin, which is microcystin, well, actually there are over 80 known analogs of that toxin. And if you look at different methods to try to deactivate, break down, get rid of that toxin, you find that some things work for a few analogs, some work for a few other analogs. There's just no way that we can get all of these toxins out with any kind of affordable processing. The only answer I can see is that we simply have to prevent these toxins from coming into the plant in the first place. And surely, if you go out camping with your water filter and you see some green water, I would hope you will not try to filter it and drink it, because it's not going to work.
I use that as an example because I think we've become accustomed to think, oh, we have water treatment centers that'll protect us from this. And the point is, this is a different kind of entity that's our problem. I want to go back to this issue of nutrients. A couple years ago, Dr. Ayres and I were working on a bill relating to harmful algal blooms, and I put in a provision to deal with the causes of it. And it was interesting. This provision got completely hung up for reasons unknown to us. We could not understand it. We had to put a lot of work in. Why is someone blocking it? It turned out a staff member who was also on the Ag Committee didn't want research looking at the causes of this, lest we demonstrate scientifically that runoff from farms or agricultural operations, feedlots whatsoever, were causing HABs. And so this portion of the bill got just completely hung up. And I'm interested in, and Dr. Ayres, or Mr. Ayres, you deal with the economic cost downstream of this. And what are your thoughts or your experience, or yours or anyone else on the panel, of trying to reduce the upstream inputs that may contribute collectively to damage downstream?
Well, certainly the downstream economic impacts are big and not even well quantified, although in my written testimony you'll see there's a study that's about to be completed that'll give us some insight in our specific incident or case in Washington State on the economic impacts of some of these fisheries. And I agree with Dr. Anderson, at least in the Pacific Northwest example. We're not sure if there is any specific causes of the blooms that we're seeing. They are naturally occurring. Are there some specific nutrients that are coming out of the Strait of Juan de Fuca? The Strait of Juan de Fuca empties water out of the Puget Sound region, the Strait of Georgia, some big population centers. So it's not impossible to believe that might be the case. But I don't think the science has proven it to this point to be the case. But certainly if there were some proof like that, and there was some ability to reduce the impacts these HABs have on our coastline as a result of reducing some of the upstream effects, that would be a good thing. And I agree with that. But I don't think the science yet, in our case, in Washington State, says that's the case. In other places in the nation where that is the case, certainly the cost-benefit issues that you talked about earlier should be looked at and balanced accordingly.
If I could, I'd like to say that while there is some controversy about how much nutrients are involved in the red tides, marine HABs, there's really no controversy for the freshwater HABs. It's very clear that nutrients are the driving force. Nitrogen and phosphorus are the two most important. The cells need three things. They need carbon, nitrogen, phosphorus, and then some trace metals. But there's plenty of carbon. You can't do anything about that. There's some nitrogen, and there are species that can fix nitrogen. They can take unusable forms out of the air or water and fix it into forms that they can use for nutrients. And then phosphorus is the only thing that's limiting for everything. So it's important for freshwater to keep the phosphorus out. And the ratio between nitrogen and phosphorus, that just determines which type of cyanobacteria blooms. So it's important to get them all out. But it is clear that with the freshwater issue, reducing nutrients will reduce the occurrence. But it's a very long time frame where you can reduce nutrients in an area that annually has HABs. It'll be a long time before you can get the nutrient level down to where you won't have them. There are a couple reasons for that. We've already dealt some with the point sources by reducing nutrients coming out of the pipe. As has been said, it's much more difficult to deal with the non-point sources. And we need better research and effort into best management practices to reduce the amount of nutrient we're putting on the land to begin with, and then to find better ways to contain the runoff and maybe recapture the nutrients there before it finally gets into the freshwater.
Thank you, Dr. Baird, and thank all of you. Right, Dr. Baird, this has to be the most fascinating committee in Congress. Significant things, and hopefully learn enough to be able to react to what it is that we're learning, because it's impacts on us in every walk of
I could make one more comment
do,
about
sure.
that. I was in a kind of in the middle of an uncomfortable situation in Florida related to this nutrient issue. And you're talking about competing interest. The last couple of years, I was invited to talk at a number of localities in Florida because they were trying to really rush legislation that would say in our locality, you cannot use certain types of fertilizer, you have to limit the amount you put down. They wanted to pass restrictions on fertilizer usage because, you know, they have grass up to the edge of canals and all that fertilizer going in the water in big blooms. But on the other end, you have the huge agricultural interest in the middle of the state who are doing lots of farming and using lots of fertilizer, and they're coming down the rivers and getting these localities. And so there was a situation where the state was trying to pass a fertilizer regulation that would say, this is what we're going to do, and localities cannot do anything beyond this. So the localities were trying, before the state passed theirs, to get their placeholders in place so that they wouldn't be blocked from passing legislation on fertilizer. So we really need some kind of national leadership to help the localities and the states see the best road to take to do the right thing.
Thank you very much, and thank all of you for your comments. We appreciate you being here. Under the rules of this committee, the record will be held open for 2 weeks for members to submit additional statements and any additional questions that they might have for the witnesses. This hearing is now adjourned.